wherever you're joining in. You're most welcome to Renew Education January edition. Ideally, it is an exciting one again for 2025. 2024 has been an exciting year for us, and as we said bye to it, we had a number of things that we'd be proud of as Renew Technologies. Joining in from wherever you are, I am Exa Shadrack Philbon, and I'm going to be the host of our virtual workshop on solar design, installation, and entrepreneurship. And I am really excited to have all of you on board. Those who are joining in for the very first time, you're most welcome. Those who have been habitual attendees, we want to say thank you very much, and thank you for the recommendations you've always been making and increasing our reach for, our series. Just to give a glimpse to those who have no idea about what Renew Words Technologies is. So Renew Words Technologies is an African-founded organization with the three principal goals. First one is to promote climate change awareness and renewable education. But secondly, also to provide cheap and affordable clean energy solutions. And then that through our expertise curriculum on renewable energy, we aim to Shalom. Yes, are you getting me? Let me make a recap of whatever I've said then. Just to say once again, you're most welcome for this 2025 January Renew Education Series. I am Exa Shadrack Philbon, and I'll be your host for this virtual workshop on solar design, installation, and entrepreneurship. I want to say thank you to those who are joining in for their very first time, those who have been habitual attendees and making recommendations to more participants to join in our new education series. We want to say thank you for always giving a hand up to the initiatives of Renew Words Technologies. From the first place, let me get those who are not familiar with what Renew Words Technologies is, just a glimpse of what Renew Words Technologies is. Renew Words Technologies is an African founded organization, and with three principal goals. The first one is promoting the climate change awareness and renewable energy education. Secondly, promoting, providing clean and affordable energy solutions. But also thirdly, through our expertise curriculum, we do intend to empower the next generation of young energy educators to propel and drive to the sustainable energy future that we always hear in great conversations. And over 2024, we had renewable energy making really great contributions, giving insights on international policy negotiations and all of these frameworks. Particularly, I think I could refer you back to the August edition where we had COP28 that was in UAE, and it was a strategic roadmap to COP29, which we had in Azerbaijan. And we're again glad to have that debrief coming in December. So it's a great opportunity. Those who are joining for the first time, you have been habitual, there is still a lot more to learn. And for this particular webinar, I want to say that we are joined by two wonderful panelists. I'm already so excited to see people making, notice of themselves, and to all of us in the chat space. Please, if you haven't, you please note in your name, the chat space, and where you're joining it from. It would be very wonderful for us to take note of that. Yeah, I want us to get very quickly to this exciting moment, and allow me read the profile of this wonderful panelists whom we are going to have. We have Engineer Bello Ilosami. Engineer Bello Ilosami is an energy associate at Renewworld Technologies, and as a multifaceted professional with a background in mechanical engineering, thermal fuels and energy systems, and an MBA in leadership and management, Ilosami brings together technical expertise, business acumen, and social impact experience to drive sustainable growth and development. With a strong passion for fostering economic growth and improving lives, he combines his engineering experience with innovative thinking and leadership skills to empower Africa's future leaders. Through initiatives like TRIL, Ilosami and his team has worked with over 100 students across 6 schools in Lagos, Nigeria, cultivating a profound understanding of leadership, collaboration, and nation building. At Renewworld Technologies, he leverages his skill to collaboratively drive the push for democratizing energy education, and especially the most vulnerable communities, to improve access within Nigeria and Africa at large. He's always seeking to leverage his unique blend of skills and experience to make a meaningful, impact in learning and development. Interdisciplinary research, sustainable finance, international development, climate energy infrastructure, and renewable energy integration and optimization. Just in the last slide, if I can, he is a strong advocate for collaboration with like-minded professionals and organizations to drive sustainable development and create a bright future for Africa and beyond. That is the panelists that we have in this session. It's going to be starting off. In case you are an explorer, I mean, don't have a foot yet in the renewable energy space. If you are also, a navigator, you've been here for around, or you are a champion, you are an expert of renewable energy, and particularly solar, we all have an equal footing, because the multifaceted potential that comes with our speaker is going to be able to give a hand up at all the different levels of the ladder we are in. Without further ado, allow me to welcome Engineer Bello. Please, Engineer, just give us the very background of it, the very introduction to solar energy and the components, and get our fitting to that. Thank you so much.
All right. Good afternoon, everybody, and thank you so much, Shedrack, for that warm introduction. First and foremost, just permit me to have my video on because of my video off because of strong here this afternoon. Again, I want to say thank you to everybody for being here this afternoon, particularly to Renewworld how these skills to improve energy access across the respective communities. Just as Cedric said, Renewworld is committed to ensuring that the underprivileged and marginalized communities have access to affordable solar sustainable energy solutions, particularly ones that are climate friendly, and also develop skills relevant also in those communities, just to ensure that we can, as fast as possible, drive these sustainable development goals within those respective communities. So one of the things that we do is this renew education that we have monthly. And today we'll be having this Renewworld Solar training. And I have the opportunity, to just have these conversations with us so that we can get an insight as a preparation for the other part. So we'll begin now. Next slide, please. Yeah. So these are the brief things we'll talk about. Just look at the introduction, the technology, some of the components, and a few calculations. Okay, I'm sure that we would have a nice time together. The next slide, please. So please, at any time, please feel free to make comments, ask questions as we proceed. Okay, so essentially, solar energy is not something that's on there, but at least you must affect solar energy. And of course, when you hear solar, the first thing you are thinking about is essentially just energy from the sun. Okay, so and of course, we know that that energy is clean energy, is renewable. Researchers and experts estimate that one day of the sun is enough to provide enough energy, the energy demand of the year of the whole world. So it's that a lot. So it is produced through there are a lot of the reactions that are going in the sun, right? So for those of us that have science background or technically inclined, you understand that part. And currently it is the most abundant resource that we have. Okay. So something that is also very important when we start to talk about solar energy systems is what we call solar radiation, right? That is how, radiation essentially as energy travels without a medium, so the sun gets to us from here. But there's a particular component of that is important, and it's irradiation, right? Irradiation is the amount, is the intensity of that energy that comes from the sun in a particular area, right? And that will be important as we consider the conversation. So there's solar energy, the energy that comes from the sun that we get, but over a particular area, that intensity that is available in that area is what we call irradiation, right? So next slide, please. Okay, so we now begin to look at the components of the photovoltaic technology. So already you can see solar panels. No, go to the previous slide, please. Welcome to this. Yeah, so this is one of our outs in renewable technology, right? So in this picture, you will see solar panels, you will see some of this. So we'll look at some of those things briefly again. So next slide, please. So solar panels, essentially, there are different kinds of solar panels, right? The most favored one is the monocrystalline solar panels because they are more efficient. Okay. The Nonetheless, right, the other ones have their advantage, the polycrystalline and then the thin film. However, some scholars argue that to get the best of both worlds, particularly in a home system, you can have a mixture of the monocrystalline and then the polycrystalline. The major challenge with the monocrystalline is that it is susceptible to heat, so it quickly gets heat build up. And once you begin to get heat build up on a solar panel, your discharge rate becomes higher. The solar panel is losing its efficiency over time, and before you know, it's losing capacity to perform as supposed to be. So with that blend, you can get the best of a place of high temperature and also the efficiency of the solar panel. So you have that. And then for the charge controllers, you have two essential major types. You have the PWM and the MPPT, right? The MPPT is generally the ones that is more acceptable, okay? And it's just because it is easier to use, one, and it is more reliable than the PWM. So this is essentially the reason why you want to use data charge controller. Next slide, please. Nonetheless, in more modern designs, charge controllers have been eliminated from solar system designs because they have been built into the inverters now, right? So in more modern designs, you may not necessarily not see charge controllers as such into it. So essentially, this is how a solar photovoltaic cell works, right? So you see the sun as the energy source comes to the solar panel where the energy conversion takes place. So for those of us that I'm trying not to sound too technical, but when you have the PN junction, it smells like electricity, right? So, but when the sun hits the rains, there's that generation of electricity, and so it can come into where it is being collected, whether you're having your charge controllers in more older designs or in the more modern designs going directly into your inverter. Then you can charge the battery, and then you can have the energy distribution where you are using it particularly. So are you using directly to a load, or you are using it to the grid, depending on the kind of connection you want to have. And also, what is also important in these kinds of settings and situation is if it's a hybrid system or it's a standalone system, right? So are you using complete solar energy in the building, or in the place where you're using it, or you are using it in combination with maybe the main grid power, or maybe in combination with some diesel generators and the rest. So those are kind of things that are also important when you're looking at how this thing works essentially, right? So you see at the lower part here, you will see how that the Sunray works into. This just goes into the specifics of how it works. But let's move to the next slide, please. So when you're trying to put your solar installation, one thing you should be conscious of is shading. Okay, so we'll see that as we go on. Okay, so this essentially for a home system, right, which is particularly what majority of our focus is essentially the simple circuit of how it works. Okay, so we'll see that further in the next session. So let's go next slide, please. Now, so when you are beginning to design a solar home system, there are four major things you want to look at, right? The first is the energy requirement. That is very big. You want to know what is the energy requirement of this particular place, this particular system that I'm designing for. Then you want to know what is the irradiance. This is important in sizing your batteries, your inverter. You will see some of those things as we proceed. Okay, then of course, cost, you want to consider cost, you see some of those things as well as we proceed. So then what in the process, safety is also very paramount, both during the installation and then in the use. So you want to adhere to basic safety principles as we proceed. Next slide, please. Okay, so to design for a solar PV system, there are four basic steps that you carry out. Okay, we will not have the time to go extensively into them, but we'll just look at them briefly. The first thing, you want to carry a working audit. So I have a picture. The next image, please. There's an image of, yes. So here you see an image of what a working audit look like. Now that working audit is just for you to go into the building, to look around, to look at the appliances and get the rating. So you see how it's done here. What is the quantity? What's the rating? Then the operating time. How long is it used for? So for example, if you have an air conditioner that you use 24 hours, and they are saying because I'm installing a solar system, I can reduce it to 12 hours, right? You take note of what that calculation, because that's what you are going to use in doing your calculations. Then you have the total calculation. Now, somebody may want to ask and say, but I can easily get my load requirement from energy, right? I don't need to go to this. What I don't want to do is I have a energy that can get my load requirement. Why do I need to give it energy also? And the reason is it means that
Hello, Ilesami. The voice is not clear again.
Okay. Can you hear me now?
Yes.
Okay. Thank you. What was the last part we had?
About the air conditioner and having it, if you want to get it for, you reduce the amount of time you would need to factor in.
Okay. Thank you. Okay, so I said that you may want to ask and say, but if you have the energy bills, you don't need to go through this audit because you already have the energy requirement from your energy bills. Why do you want to do the audit? And I'm saying that that's going to be a good question because there are two major reasons why you still need the energy audit. Number one is because of a concept we call retrofitting, right? So retrofitting is you going through it and looking at, so sometimes some buildings are consuming more energy than is required. So you have what is called energy saving appliances, right? So a building might have 6 bulbs, whereas you can use 2 bulbs with lower wattage for the same purpose, right? So, but that is one reason. This other second important reason is particularly because of the inverter system, and it is a concept of what we call starting current. So when you start up appliances, especially the ones with motors, something like your refrigerators, right, your air conditions, those kind of that pumps, compressors, usually their startup energy is usually very high than the usual operating energy because of what is called the starting current. If you don't do the energy audits, you cannot know the starting current. If you don't know the starting current, you cannot properly size the inverter system and then the battery, right? So that's why this energy audit is very important. Energy requirement is one part of it, but you also need other informations. So this is a simple template of how it's done, right? Next slide, please. I hope you can still hear me. Okay, thank you. So now, so like I've said, so I've talked about some of these things. So when we want to, so let's go to the next slide. Let's go to where the calculation is so that we can just look at it directly because of our time. I have two calculation examples here that we want to. Okay, so let's look at this basic example. You say a household in Lagos, Nigeria, consumes an average of 400 kilowatt hour of electricity per month. So forget the fact that this is Nigeria, this is basic design for anywhere, right? Even if you are doing the design for an industrial setting, it's basic. You might have one or two slight adjustment, but it's just generally the same principles. So they want to install a solar PV system to offset 60% of the electricity consumption. Now, remember I spoke about a hybrid system. This is what this particular customer wants to do. So this customer is not saying I want to go off the grid completely, or I want to stop using petrol or diesel generation completely, right? This customer is just saying my energy bill is too much, all right? So I just want 60% of it off on solar energy, right? And so when you want to, so this person is not going for a complete overhaul, the person is taking an hybrid system. So you follow that same procedure. Now, if you look at point C says assume an average of 5 peak sun hours per day in Lagos. Estimate this total number of solar panel needed, considering each panel has a rated power of 200 watt. We will explain why it's important. Now, I want to pick that peak sun hours. Now, per location, the amount of hours you can get good sunlight differs. And of course, it's solar energy. So if there's no solar, if you can't get good sunlight, you cannot get enough out of it. You will see more of that in the next session, but you just need to know that in this particular calculation, it's important to know that amount. So next slide, please. Right, so this was a rough example. So you have done the basic calculation of how much you are needing per year. Okay, now this calculation was done per year. Usually, what you will find in many places is to have the calculation done per month. It really doesn't matter. The sizing it doesn't particularly affect the sizing. But so if you want to do it per month, it's just to say you're dividing it by 12. It's just basic that, right? So when you have that, you can now begin to look at what is that offset you are using. So for here, the annual consumption is 4,800 kilowatt hour. So what is the offset they are doing? 60%. So you're just taking 60% of the annual consumption, which is giving us 2,880, right? So there are a number of things you also consider. Efficiency. So for example, when you are designing, it's a rule of thumb that your inverter system should be about 25, some literature will say 25 to 30% higher than the total energy demand. The reason you have that rule of thumb is just so from experts and then from practice over the years, we have found that because of starting current, for example, right, and then because of surge, whether from starting current or maybe there's a fault in line, you have that surge system. So you want to have 25% above. And the best inverters you generally have, some literature argue, but generally between 85 to 95% efficiency, right? Those things are also important in some of the calculations that you will do for a very large, for example, if you are considering a mini grid, right? So when you do that, so you have that system size. And by the time you calculate system size, you are seeing the system size of what you need is around 1.558 kilowatts. That's after dividing this energy offset, which is what you want to do, by the peak sun hours multiplied by the number of days you have in that year, right? So when you do that calculation, it gives you that system size. Now that system size divided by the rating. Now, so I'm saying that the amount of energy output I need, right, is going to be this per day. This system that I'm calculating now is per day. That's why I'm dividing by 365. Remember, our total energy is in per year. Now, so because I'm needing that in per day, I'm dividing by 365. So if I need a 1.5, remember that the question has already told us that the solar panels that's available to use is 300 watts for one.
Mr. Lefami.
Hello, we have lost you. Yes,
Bring
hello,
him down
we
to
have
front.
lost you.
Okay, can you hear me now?
Yes.
Yes,
I can get you now.
So what was the last thing you heard?
Yes, hello, you are still on considering the other factors, leaving out the other factors that like system efficiency and inverter losses during actual design,
Okay,
but then
so
getting
I
to
said
the
that.
simplified example on the next, just on the left of
Okay,
this
so I
slide.
said that when you're looking at the system size, right? The system size is considering the amount of energy you need per day. That's why you are doing the calculation by the annual energy that we already have, divided by the peaks on our number of available time that the solar panel will be generating, divided by the number of days in a year. That gives us that amount. And I said to know the number of solar panels is to say if I need this output per day from the solar panels, and I have a 300 watt solar panel, how many 300 watt solar panels am I going to install? So it's simple arithmetic. You divide that output over that number of solar panels, right? So that wattage of solar panel, rather, it gives you the number. Can you hear me now? Okay. And I also mentioned that for standard in industry, we are saying 25 to 25%. Some literature say to 30% higher for the inverter size. So let's go to the next slide so that we can see what I'm saying. Okay, so now this system now is for a normal system. Now this one has also taken cognizance of, no, go to the next slide. Next slide. This one has taken cognizance of the solar irradiance of the area, the amount of energy, and then the backup duration. Now the backup duration is important in an event where you cannot get enough sunlight to generate electricity. How long should the solar panel last? Now, another point of note is also that when you are designing, can we still hear me? So when you are designing for, thank you, when you're designing for a solar system, the batteries usually are put there for periods where you cannot use the electricity directly. So for example, if you are in a place where you have constant electricity in the night time, maybe from 6 p.m. to 6 a.m., there's constant electricity, right? Only but from 6 a.m. to 6 p.m., there's no electricity at all. You might, depending on a few factors, and that is a case-by-case basis, so I may not be able to call the assumption, that's why I'm not going to those specifics. You might consider not having maybe as much battery system as you would want to have, or not having any battery system at all so that you can use directly, right? That severely also will drive down the cost you want to have. So you can just use directly from the solar inverter system. So you have that here. So let's go. Let's move on. Let's move very quickly. My time is almost up. Next slide. So remember, we have done the daily consumption. We know how to do that. So now you are seeing the solar irradiance, right? The solar array, to know what it is essentially the same thing that we have calculated from that place. Now this is something that has been introduced here, and it is backup power. Now, so what is the energy we are going to require for backup power? Can we still hear me? Okay, thank you. What is the energy we are going to require for backup power? What's the daily consumption, right, of that power, what daily energy consumption times the duration of days? So if it's going to consume 450 kilowatt hour per day, and we know that for 2 days, it's possible that we may not be able to generate in certain seasons. So we need minimum of 900 kilowatt hour. Do you understand? 900 kilowatt hour. Okay. So now, depending on the kind of batteries you have, usually it's recommended that we use lithium ion batteries because of their efficiency and their ruggedity, right? And so what you do here, there's something that is called, there's a more complex calculation that involves you calculating for the depth of discharge. Generally speaking, it's acceptable to be 50%, right? When you calculate that depth of discharge with depending on the efficiency of that particular system, based on this rating, you see that there's a slide that talks about that before. You cannot get the total amount of batteries you are going to require, right? Now, based on the fact that you now need 90 kilowatt of output, that's not going to inform your inverter selection. However, we should note this. Usually, when you are purchasing your inverter, that output is not just the most important thing. So can we quickly go back to that side of energy load? Okay, no, don't worry. But there's a place where there is, okay, thank you. If you can go back there, thank you. There's a place where we did an energy audit. Now, if you check that energy audit, you will now need to look at the appliance that has the highest starting current. So for example, when you look at it here, the highest load on the rough plans is this first one. I think it is about 12,500, right? Just look at the highest load for, if you just take a rough plans, right? About 12,500, right? So when you look at what is the starting current on this particular air condition, let's say starting current is maybe 2 amperes, for example, right? Let's just say that. Okay. So maybe that's the highest starting current. That's not going to inform the current capacity.
Yes, better we have lost you.
Okay, so I'm talking about the inverter capacity. Can you hear me now?
Yes, yes, we can get you there, right?
All right, thank you. I'm saying the inverter capacity is predicated on the highest starting current of the appliances that we are going to power with solar system. All right, so let's continue. Next slide. So you just want to put that in mind when you're selecting your inverter. So after you have known what it is, you want to put that in mind. So there's something that's called levelized cost of energy. In layman's language, levelized cost of energy gives you how much you are getting per kilowatt hour of generating over a system design over the lifetime. What that means, I will explain. If I install a solar system, can you still hear me? Thank you, sir. If I install a solar system, maybe and it spans for maybe 5 years, 10 years, for example, or any energy system actually, not just a solar system, any energy system. Over that period of the lifetime of that energy system, how much is it going to cost me to generate 1 kilowatt hour of energy? What is the amount that is costing me over that lifetime? That's what the levelized cost of energy helps us to calculate. Now, you will see here a very simple calculation. Total lifetime cost over total lifetime electricity production, right? Now, here you have to consider things like, for the total lifetime cost, you consider things like capex, the capital cost for of course, you are doing your mounting. If it's wind energy, you are doing all of those capital capex costs, the purchase, all of that. You're also considering operation and maintenance cost, right? You put that into place. For wind energy, for example, you consider the resource. You want to calculate all of that into the total lifetime cost. However, this model is a simplified model. Can you still hear me? Okay, thank you. So for very large projects, right, it's considered that you also have to consider what is called the time value of money. So there's a more expanded calculation that some experts, some scholars argue that is more suited because of the consideration of lifetime, time value of money, I mean to say, and the other issues like depreciation cost that you can use. But basically speaking, once you know the total lifetime cost, including operation and maintenance, so total lifetime cost is essentially capex plus operation and maintenance, essentially that over the total lifetime electricity production that is going to be over that lifetime of that energy system. That's going to give you how much you are going to use for what is going to be your levelized cost of energy, how much money is going to cost you to generate 1 kilowatt hour of energy. All right, so I don't know if we heard me up to this point. Okay, next slide, please. So what is the benefit of solar energy? So it's not just because of the fact that your energy bills are high. That's not the reason why we're using solar. Yes, that's why, but that's not the only reason. The other reason we are using is because of the environment. So you see, number one, top of it is reduction of greenhouse gas emissions. right? Go figure, right? Your generator, CO2, right? The CO2 that comes out of the generator, right? All of those things that comes out, it helps us ensure that we are removing all of those things out of the place. We are not destroying the environment, okay? And so if by implication, you are having decreased air pollution and water pollution as well. So it's because we will not be drilling for oil, there's no oil spills, you are not damaging habitat and all of those things. And also, which means natural resources are conserved more, and then also it means also water resources are conserved more, implicatively, right? So you are not using water, for example, in managing generator systems, in heat, all of those other fossil fuel requirements, right? And so that invariably leads to us mitigating environmental degradation by a significant amount. So next slide, please. And I think this last slide is really very important. Solar entrepreneurship is okay. Now I have understood all these things. I may not have known them before. I know them now. Can we still hear me, please? Can you still hear me?
Yes, hello.
Okay.
Can hear you.
Thank you. So is now I've learned all of these things. So what can I really do? What are the paths for entrepreneurship that we have? So for example, look at RWT. Thank you for the feedback. RWT is also exploring one of the areas of entrepreneurship in renewable energy, even though our focus is not only solar, but it's one of the ways. And you are saying what's RWT doing that is so for example, the solar training. You see that solar training institute, a solar training like we are doing like this is part of solar entrepreneurship, right? So we have our own product, our solar kit, for example, that we have developed to make energy access in marginalized communities affordable and accessible, right? It's part of solar entrepreneurship. So you can have those products. You can be an installation professional. You can be the one to install. Then you can do you can be a PV design specialist based on all of these things we have talked about. Now, it's also important to note that in modern times, there are software that you can use for more complex projects. If it's not just a house, if it's a complex project, a mini grid, for example, PVCs, OMA, OpenSys, and stuff like that. There are a number of softwares you can use, right? Actually, you can use MATLAB if you are very good, you know what you are doing. You can use MATLAB too for some of those things. So PV commissioning and maintenance specialist is also part of the entrepreneurship that you can do. So when a PV system is designed, you can be the one to verify like your QA, and when you need to do some basic maintenance. So for example, inverter repairs and recycling, the inverter has a problem, it has to be repaired. Solar auditing, this I just mentioned now, how to go into a building, look at the analysis of the building, determine, okay, how do we want to do it? You will see some of these things in the next sessions, the tilt angle of those things, solar auditing is part of it. Solar pump and irrigation services, you can provide these services for farmers in rural areas so that they can use it to, improve their agricultural product. Consultancy, right? So that's some of the things that you can also do. Solar blogging, right? I think this one is even the easiest for anybody to just start. It's just for you to, have knowledge and then talk about your knowledge. For example, somebody say, how do I want to start? LinkedIn. Many of us are on LinkedIn here. Keep putting out posts, okay, this is what I know about solar energy, this is what you need to learn as well. And some of the things we can do under solar entrepreneurship. And this is not exhaustive at all, but these are just a good number of things that we can do. So I will take questions if there are any questions now. Thank you very much.
Right, amazing. Thanks so much, Bello, it has been an exquisite introduction from a beginner level, and a lot of opportunities are reflected, especially for the entrepreneurship part, because I think many people who have technical expertise do not think they have a place to benefit with solar energy space. And I think that was a place. But just before I get to any other question, Tito did raise his hand during your presentation. So would you please share that question right now? Yes, Tito. All right. Tito, I can't see you yet speaking up, but any other participant in this call, if you have any other question, you may decide to be in the chat space, or you will have a time at the end of this session. We'll certainly be able to share that question, both for our first and then our second speaker. Yeah, so just carrying it over from the point of entrepreneurship, I think that's a very exciting point in next sector, because we cannot talk about the design, the innovation, when we do not have the entrepreneurship connecting it, because that's how much we can transform society. We're just going to have our second panelist coming on board, and this is going to be a virtual practical, I should call it, on steel solar design installation. And allow me first of all read the profile of Engineer Simon before we get to get the conversation from his end. Yeah, in just a few hours, I'll be reading the profile of Engineer Simon Oloyo. He's a graduate of electronics engineering with more than 10 years experience in electrical power systems and renewable energy. He is well trained in solar PV technology with a certification from National Power Training Institute of Nigeria, Council for the Regulation of Engineering in Nigeria, Nigerian Electricity Management Services Agency, the district in case in Germany for international. Yeah, that is just the German description of the same. Advanced scholar of power, oil and gas, Renewable Academy of Berlin, that is Germany, and USAID or Power Africa. Renewable Energy Solutions for Africa and Paderborn University. He has done research and teaching for development grids. He has extensive working experience in solar PV system design and very conversant with project development and finance. Installation and commissioning, troubleshooting, maintenance and system designs, design and installation of distribution transformers, electrical safety and system protection. Just getting to the second last line. He has helped several startup companies and institutions to develop their technical. Simon is the lead technical consultant with Electricity Technology Limited, SolarSeed Limited, and SolarSeed Power Limited, and lead technical instructor with the Renewable Energy Technology Training Institute, that is RET in Nigeria. I mean, he's coming with all that magnitude of experience, and as a seasoned professional, it is a high time we listen and good to have the virtual practical coming from his end. Engineer Simon, please do unmute and get the insights to our end. Thank you so much.
Yeah, thank you very much, Shedrack. And I want to say thank you to Shalom for this great opportunity. And to everyone, I want to say Happy International Education Day. Let me share my slide. Okay. Please, can you see my slide? Okay. Thank you very much. So, Engineer Bello has did a great job for us. I think he also make this presentation an easy one for me because he has touched some basic aspect of the solar PV system design. And in this section, we'll be looking at the installation aspect of the solar system. A quick one, let's look at a simple overview of what the solar system is all about. And from my slide here, you will see that the configuration and how the power flow from the energy generation plant, which is the PV array, to the inverter. Then you also have a battery. Then from the inverter, we have our output. Also, grid is also integrated in this system. We'll be looking at various installation. And the next one here, you will see that there is also introduction of a external charge controller. We all know what the charge controller is all about. Let me move again to another different setup. Now, in this setup, you will see that
So sorry, the presentation is not on slideshow. I don't know if from our own side to get a much closer look at the presentation.
Okay, sorry.
Okay, perfect.
Is it perfect now?
Yes.
Okay, good. Now, from the PV array, you will see that here there is a breaker between the PV array and the inverter. This inverter setup here has an inbuilt charge controller. The previous slide has an external charge controller. So this has an inbuilt charge controller. That's why you are not seeing any charge controller at this point. So the breaker here is for us to be able to break the power flow from the PV array to the inverter whenever we want to carry out maintenance or there is fault on the system. So it makes it easy and also make the work to be very easy. As we proceed, I'm going to be showing you another accessory called a PV combiner box. So this is just a typical and overview of what it is. So here we have our inverter. Then we also have the grid setup. Here, this is the meter. And from your meter, between the meter and the inverter, there is also a breaker. Here is an AC breaker. The other one is a DC breaker. So this is an AC breaker. And from the output of the breaker, you have your changeover switch. So this changeover switch enables you to change either from the inverter or to the grid. It also helps you in times of troubleshooting or maintenance to isolate the grid from your inverter, because the inverter automatically switch to either grid or the battery backup. Okay, but the changeover is good so that whenever you want to carry out a maintenance on the system, you can actually switch to the grid. Then from your inverter side, you go ahead to do your maintenance. Okay, so the output of the changeover is to your distribution board. Here, after our changeover, you will see that there is also another breaker here. So there is a breaker between the changeover and the consumer here. Okay, so then in this setup, we have a battery bank. We have a battery bank. The essence of this battery bank is for you to be able to have the system running even when there is no solar. So at cloudy days or at night when there is no solar, the battery bank serves as a backup for you. Then there is need for you to have a breaker also between your inverter and your battery bank. So I move to the next slide, showing a different setup. Here we have is also an inverter with inbuilt charge controller. And you will see that this inverter here has about 6 PV module of 330 watts connected in series. So all these PV modules are in series to the inverter. This is an high voltage inverter. And then again, we have a battery bank. Aside the battery bank, we also have the grid input to the inverter. Then the output of the inverter, we have also a breaker. You can see that we introduce a lot of breaker in this system just to be able to protect the installation and to protect the investment, because you will agree with me that the cost of a solar system is not something that you have to install and not provide some of this external protection. Though the inverter comes with the protection also, but there is need for you to have an external protection. So as I proceed, you get to understand why you have to have these protection put in place. So basically, we have what we call a DC couple system and AC couple system. Here on the slide is a DC couple system. So for a DC couple system, we have a PV array. This is our PV plant here. This is our PV plant. Then we have, after the PV plant, you have a charge controller. The charge controller regulates the charging of the battery, because the charge controller will be charging the battery through what we call a DC bus. There is a DC bus after the charge controller. This is the charge controller. You can see DC to DC, converting is a DC input and DC output to a DC bus. Then our battery bank is connected to this DC box, and also the DC side of your inverter is connected to the DC box. So the output of the inverter is connected to the consumer here. This is the consumer. You can also see that in the DC couple system, is connected to the grid. So you have the grid connected to the AC bus. The grid is also there to charge the battery. You can as well regulate it. You can as well introduce a switch, most especially when you have like if you are on a prepaid meter, for instance, and the most essence of your solar system is to save cost. So there is no point that during the day when you have the solar radiation and there is power from the grid and you are still charging your battery with the grid when you have the solar. So is a no. So you can isolate the grid during the day and make use of your solar PV array to charge the battery just to save cost. Now let's look at a typical DC AC couple system. So the first one is a DC couple system, and this is an AC couple system. So in an AC couple system, you have what we call a PV inverter. But in the DC couple system, we have a battery-based inverter. So in this, we have two inverters now in this setup. There is a battery-based inverter, which is this, charging the battery. Then there is also a PV inverter that supply that supply output to the load. So we have the load here. So the essence of this battery-based inverter is for you to be able to charge the battery, to have a small battery bank to power some critical load, maybe at night to power some lighting point when the PV will not be in operation. Okay. Then there is the grid or the generator. So you can, here, there are some things that you are not seeing here, but is integrated into the system. So there is a changeover that enable you to switch either from the grid or from the generator to charge the battery. So, good. Yeah, we have what we call a grid-tied or on-grid solar power system. So typically a grid-tied system send energy generated also into the grid. So in this setup, what you generate, you can as well send it into the grid. You can save it into the grid. Let me use that word. This setup is typically like your saving account now in the bank. Your saving account in the bank, you save money in the bank, and as you save money in the bank, you can be withdrawing the money bit by bit, and at the same time also deposit, save in the bank. So for this grid-tied system, you can generate excess even power during the day and save it into the grid, so that at night, when your solar PV system will not generate electricity, you can now take from the grid. So there is also a meter. You can see there is a meter between your PV inverter and the grid. So this meter what you send to the grid, and also what the grid is sending back to you. Okay, and in this setup, you will see that there is no battery backup. But then, thanks to BESS now, BESS is gaining more popularity now. So we can integrate BESS into this grid-type system. Okay, so let's move to off-grid system. Off-grid system, in an off-grid system, is a system for a remote location where grid is not available, or where there is a distance to the grid. So you also compare the cost of extending grid to those locations and the cost of setting a PV system in those locations. Okay, so in the off-grid system, there is no grid. So what is solely available there is your PV system. And then you can, there is what we call energy mix. You can have wind system integrated. You can have both wind and solar. You can as well even have a gen set to also take care of energy at night, and you can have good. Can you still hear me? Can you hear me, please? Okay, good. Thank you. Now, lastly, we have the hybrid system. So for the hybrid system, is like the combination of the two. You have the grid and you have the battery bank. Then you have your solar system, then output to your load. Okay, good. Now, in all of these setup, there is something that is very critical in solar PV installation. And the first thing to know is to understand the site, understand the energy need, study the load profile of the site. Engineer Bello has mentioned some of these during his presentation. So please, for you to have a successful and a reliable solar PV installation, your site inspection and site analysis is very, very important, because this prepare you for the installation. This help you in your component selection, the battery bank, your inverter selection, the type of installation to adopt, and some other things that are very essential and critical in your installation. And for residential, there are things that you can easily get away with, because for residential, we are looking at most likely some small installations, some smaller capacity, like a 1 kilowatt system. So there are some of these things that you can easily get away. But for a commercial and industrial system or a mini grid system, please, your site assessment is very, very important for you to have a successful installation. And one of the things that you have to consider in your site analysis is for you to know the availability of the grid is very, very important. Like I mentioned, let's say, for instance, an off-grid location now. Before you proceed for an off-grid installation, you need to visit the remote location and understand the energy need of that location. Find out the distance of that location to the grid is very, very important. Then how reliable is the grid, okay, is also important. Then also, do you have a gen set on site? This is talking about your commercial PV system, and also even for residential system. Okay, so is there a gen set on site? You need to know what is the capacity of the gen set, because I see that some funny installation where the inverter is, for instance, a 10 kVA inverter, and the generator set on site is also a 10 kVA. It's not going to work. There is no way that a 10 kVA generator will power a 10 kVA inverter. They are of the same capacity, so it's not going to work. Then the grid configuration is very, very important. You need to understand, is it a 3-phase or is it a single phase? So if you have a single phase load, you cannot deploy a 3-phase inverter to power such load. If your load is a 3-phase, let's say industrial motor, for instance, that are 3-phase, there is no way you deploy a single phase inverter to power a 3-phase load. Another thing that you also need to pay attention to is the voltage level, and also the near resistance point, okay, to the grid. I've mentioned that. So you need to understand the voltage level. Now, for your grid connected system, because you are sending what you are generating from your PV plant to the grid. So, and the PV inverter, their output is within the range of 400 to 600 volt AC. And you know, our grid system in Nigeria, we have, though apart from the transmission level, for the distribution level, we have a 33 kV and we have 11 kV, and which is also being further stepped down to 415 volt, and that's 3-phase, and 220 volt. So you need to understand the grid voltage level. So is it an 11 kV voltage level? If it's an 11 kV, it means from your PV inverter output, you are going to be feeding it into a step-up transformer. There is what we call step-up transformer. We have a step-down transformer. But in this case, you are going to step up your 400 or 600 AC volt to 11 kilovolt in order to what? To be able to play on the same voltage level with the grid. So you need to understand the grid voltage level. Then another thing that is also critical is the quality of the power, the quality of the power, talking about the voltage drop, the phase unbalance, voltage fluctuation. You need to also understand this. This enable you to prepare for your voltage, like stabilizer in this case now for residential, because if you are going to be installing your inverter and connected to the grid to charge your battery, then your voltage has to be stable. So there is a need to introduce a voltage stabilizer between the grid and your inverter input, because inverter has threshold, voltage threshold, and some is between 180 volts to 280 volts. So if your voltage is below 180, your inverter will automatically switch to the battery mode. So discharging your battery, taking power from the battery and not from the grid. Because from experience, I've discovered this over time, that you will see clients will tell you, or your customer will tell you, that there is power supply for 10 hours, and we discovered that after outage, our inverter only worked for maybe 30 minutes, and it shut down. So most likely there is a voltage fluctuation. So if there is voltage fluctuation, your inverter will not see the grid if it's below what the minimum voltage it can take. So it's going to cut off and switch to the battery mode. So there is need for you to introduce a voltage stabilizer to stabilize it. And again, your voltage stabilizer must be a higher capacity compared to your inverter. So for instance, you are using a 5 kVA inverter, don't install a 5 kVA stabilizer. Get a higher one, like a 10 kVA stabilizer. That's between your grid and your inverter. Okay, another critical thing is the documentation, your site map, the electrical drawing of your site. Like I said earlier, some of these things you might get away with them in a smaller system, residential system, but for commercial system, is very, very important. When you want to power a factory, for instance, you need to understand the electrical drawing, the electrical architecture of the facility that you want to power. And if you don't have that electrical background, there is need for you to involve a specialist in this aspect to help you to interpret this, because these are things that cause technical issue. I've seen there are serious arguments that solar does not work, and I've argued this, that solar does work if it's properly installed. Okay, so there is a proposal that I was involved, and in the drawing I discovered that the transformer that was introduced, the voltage output, that the secondary side of the transformer is actually a 33 kilovolt. Meanwhile, this system is to be integrated into an 11 kilovolt grid voltage level. So when I further ask question, the consultant involved actually confided in me that he's a mechanical engineer, and we may need to review the electrical drawing for that project. He actually tried, he did a good job, but beyond mechanical, there is also the aspect of the voltage configuration of the inverter that is lacking. So in some of these systems, there is need for you, there is nothing wrong when you involve an expert, most especially the electrical aspect of the system. Okay, good. Another thing here is that there are some key factors that will make your installation successful. And one of these factors is that the temperature of the environment where your system is installed. I'm going to be showing you some funny installation, and you will agree with me based on the data sheets of some of inverter that I'm going to be showing you for you to understand how this inverter works. Okay, your orientation and the teeth angle of your installation is also very, very important. You all know that for a perfect installation, your PV module is to be facing south in the northern hemisphere. And if you are at the southern hemisphere, your PV module is to be facing north for you to get to be able to harvest the best from your PV module, because the sun has to be perpendicularly directly on the surface of your PV module for your PV module to perform at its maximum power output. So the orientation and the teeth angle is very, very important. You need to pay attention to that. Then also you need to pay attention to the wiring system of the site. Study the wiring system of the site. Make sure you find that if there are complicated issues on the wiring before you integrate your inverter to the system, because inverter are very, very sensitive. There are some leakage current that your generator will withstand it, though over time we damage the coil of the generator. But in as much as you are having an inverter to be integrated to the system, once you power on your inverter, it's going to shut down because they are very sensitive. Okay, so you need to find out and make sure you carry out some tests to know that the wiring is perfect. I'm going to tell you or show you how to do some of these things. So let me move. I have a limited time. Let me move faster. Okay. Pay attention to the roof type. It's very important. It is not all roof that you can mount your PV module. You need to understand the structural strength of the roof, so that not after you have installed, few days or few weeks after your installation, the roof will collapse. So you need to understand the structural strength of the roof. So if you are doing, let's say, a 500 kilowatt PV installation for a commercial installation now, and it has to be on the roof, there is need for you to engage a structural engineer. A structural engineer will be able to carry out analysis of the roof now to tell you if the roof can actually withstand the load that you want to add to the roof. Because you know, when you study the technical or the nameplate of your PV module, it also tells you the weight of each module. So multiply the weight of each module by the total number of module, which tells you the total weight. Then from the structural analysis, you will be able to know if the roof structure can withstand the load. Then accessibility to the roof is also very important. So that is why you don't need to skip your site assessment, which is the first thing even before your design. So accessibility to the roof, because like I said earlier, it prepares you for the installation. So where are you going to mount the PV module? If it's a rooftop, how do you get to the rooftop? So it enables you to prepare for the installation. Is it going to require additional machinery? Is it going to require a forklift? Is it going to require a scaffold, for instance, to get to the roof? So that is very, very important. Okay, good. Yeah, when you mount your PV module on the rooftop, for instance, please make sure that you properly fasten the PV modules on the roof. Please You can see this, and also there is if there is no space, if there is no enough space on the rooftop, or the roof cannot take the total number of PV module that you want to install, you can as well do what we call a support structure. You can erect a pole like what I have in this picture here. Okay, good. The teeth angle now. Okay, hope you can still see my slide. This is what we call the teeth angle. So if, for instance, if you place your PV module, let's say you have a flat roof now, or a flat surface, and you place your PV module or install it on at 0 degree. What it means is that the dead particle will be deposited on the surface of your PV module, and this dead particle over time will accumulate and cover and cause shading to the cells of your PV module, and this will further affect the output of a PV module, and even at times you'll be having a 0 output. I've seen the cases where a solar PV module is installed close to a road construction site. So there is accumulated dust over the surface of the PV module. So when your PV module is at 0 degree, the dust settle, and when it rains, though rain will wash it, but since it's a flat surface, there is going to be some debris that will settle on the surface of your PV module. So by teething it enables you to be able to clean the dead particle, and also when it rains, it washes the dead particle away from the surface of your PV module. So if you are at a latitude of 12 degrees, for instance, the teeth angle is to be 12 degrees. So you're going to be teething your PV module at 12 degrees. If your site location is at latitude 12 degrees, if it's 10 degrees, it means the teeth angle is going to be 10 degrees. Because if you are working with this at 12 degrees, for instance, it means that the position of the sun in the sky is going to be directly at the surface of your PV module at the peak sun hour. And the peak sun hour is actually the hour that you can harvest the maximum from your PV module. Okay, good. Now, let's look at some of these installation. You can see this installation here, the first picture here. Now, you will also see trees around this installation. There is no way this system is going to work efficiently, because these trees around will be shading your PV module, and it's going to affect the output of your PV module. Don't forget that some of these PV modules are connected in series, and you know when it is in series, the same current flows through it. So for instance, you have some PV modules that are shaded already, and some that are exposed to the sun, but they are connected in series to those ones that are shaded. So those ones that are shaded will draw down the ones that are not shaded. So this is a very wrong installation. Look at the second picture. You can see that I want to assume that it's either there is no enough space on this roof, or this roof is also not facing the south, or maybe probably the client insists that the PV module should not be installed on its rooftop. Because I've actually have a case like that, honestly, because this section involve practical. It involved practical. So there is actually a project which is a big one, is about close to, I think, 25 kilowatts, is residential. So it's a big residential system. And my partner is already looking at the figure involved. But during my site analysis, I discovered that because during site analysis, you also need to engage, interact with the client. So the client mentioned to me that he doesn't want the PV modules to be installed on his rooftop. He doesn't want it. So I told him, and around the compound, there are trees. So I told him that these trees will be shading the PV module if we are to do a pole-mounted installation. And he insists that it should be a pole-mounted. At that point, I have to opt out because there is no way that system is going to work efficiently. And if it's not working, the customer or the client will not allow you to sleep. So in order to have to be able to sleep at night, I opted out of that business. So let's look at this again. You can see that even the PV module are facing the building. So the building is already shading the PV module. So there is no how this is going to work effectively. Then there is another one. This got me thinking because these installer here have enough space to install the PV module, and I don't see any reason why this tree should not be brought down. Okay, because you can see that the tree is already casting shadow on some section of the PV array. You can see this. This will actually affect the output of this PV array. Okay, good. Now, talking about charge controller, we have two major types, the PWM and the MPPT. Please, I want to advise you because PWM is actually an old generation. It's an old technology. I don't want to believe that anybody should be doing PWM at this time. And I will tell you why. Okay, good. So let's look at this example. For a PV module of 250 watts and 24 volts, the output voltage is going to be more than 24 volts because PV module are actually, they produce or they generate a voltage that is higher than their rated capacity or their rated voltage. So it's a 24 volts PV module, but the output voltage here is 32 volts, for instance, on this for this case study. And the current is 7.8 amp. Is 7.8 amp. This is what is going to happen if you are using a PWM. Now, a PWM already understand that your system or your battery bank is 12 volt. As soon as you connect your charge controller to your battery bank, it's synchronized and to understand the system voltage. So it's going to program itself for 12 volts. So a 32 volts is coming from your PV array. It will step it down to 12 volts. So when you multiply 12 volts by 7.3, you have 93.6 watts. So the power here is going to be 93.6 watts and not 250 watts. Okay, you will see that you have already, despite you have extra 20 volts. Okay, good. Now for MPPT, which is the maximum power point tracking, MPPT has the ability to convert the excess voltage from your PV array to additional current to charge your battery. Okay, so for the same example that we look at here, you can see that the MPPT already understand that the battery voltage is 12 volts. Okay, so and you have 32 volt input to your charge controller. So the charge controller step the voltage down to 12 and increase the current to 20.8 amp. When you multiply this, you will see that you see have something close to your 250 watts. Okay, so I don't expect that anybody should still be doing a PWM at this point. Now, look at this installation. Look at this installation. This is a poor installation, and this can happen as a result of a substandard cable. It can as well happen as a result of high current from the PV array. So the system need to be properly sized from your system design. So you need to also size your cable. So you don't only size your inverter, your battery, your charge controller, and your PV array. You also size your cable. It's very, very important. Okay, good. This is still talking about. Okay, good. We are looking at inverter. Inverter should be big enough to handle your load. Engineer Bello has informed us earlier that the capacity of your inverter should be between 25 to even 30% of your load. Okay, so you need to size your inverter to be big enough to handle your load, and also to be able to handle the peak load, and also to handle the surge current, because there are actually some equipment that their starting current is actually like times 2 or 3 of their running current. So by the time you power it on, like your refrigerator, like your air condition, like your pumping machine, so when you put them on, they draw high power from your system. So your inverter needs to be sized to be able to handle it. So the technical or the data sheet of your inverter is also very, very important. It's very, very important. Please, Shadrach, you need to also help me with time, okay? Maybe I need at this point to move at the speed of light. So the technical sheet, the data sheet of your inverter is very, very important. Let's look at this data sheet. For instance, you can see we have a different series here. For the first one is we have which is 30 kVA. The apparent power is 33 kVA. The rated power is 30 kilowatt. So there is what we call the apparent power, and there is the real power. Okay, so there is the real power. The real power is the power consumed, but the apparent power cover for both the real and the reactive power. Okay, so there is the real power and the reactive power. So, and the difference between these two is just the power factor. So that's why you need to study your data sheets for you to understand what your inverter can handle, the total load it can handle, and at different points. Let me show you this. I don't know if you can see this. Maybe if it's very clear to you, is a Vitron data sheet, and I want us to look at the 15 kVA of it. Quick one, if you look at the 15 kVA of it, the actual power that it can deliver is 12 kilowatts. That's 12,000 watts at 25 degrees centigrade. At 25 degrees Celsius. So, and at 40 degrees, the power that it can deliver is 10 kilowatts. So you can see that as the temperature increases, the capacity of your inverter also reduce. So you need to study the data sheet and also your site to know if the site location, the temperature the room temperature of your site location and where you want to install your inverter is very, very important because it's going to affect the capacity of your inverter. The capacity of your inverter will reduce as the temperature increase. And a typical case study of even you as a person, the way you are going to work in the morning at, let's say, 8 a.m., 10 a.m. is not the same strength you will be able to use when it is 2 p.m. Okay? For instance, you might be able to carry, let's say, 5 bags of cement at 10 a.m., for instance. Maybe you can do 5 bags of cement for 30 seconds or even, let's say, for 1 minute. But when it is 2 p.m., you will not be able to carry the same 5 bags of cement. So your capacity is going to reduce as the temperature increases. So also some of these are our solar components. Okay, good. These are typical pictures of some of the inverters that we have around. Okay, good. Talking about the poor installation. You can see this. This system is actually installed inside the roof. You see, there are some of these funny installations that when you hear about it, you will not believe it, not until you see it. This installer actually installed this system inside the roof. You can imagine the temperature of that the manhole now, when you know, talking about when you open, I don't know if you have ever opened your manhole to see what is happening there, especially at noon. So here we have the charge controller, we have the inverter, and we have the battery installed inside the roof. Now, another thing that happens to your battery is that the capacity of your battery also will drop, will reduce as temperature increase. Another thing that happened to battery is that the rate of chemical reaction as temperature increase is what is faster. In fact, for every 10-degree increase in temperature, the rate of chemical reaction is almost like double. So it means your battery will charge faster and it's going to discharge faster. Okay? And the battery life is also based on cycle. So we assume that for a day you have a cycle. So each day is a cycle. So that is a charge and a discharge. Let's assume that. So it's possible for you to have 2 cycles in a day or even 3 cycles because your battery charge faster and discharge faster. And if, for instance, your battery is supposed to have a life of 4 years, for instance, now, and at 25 degree Celsius, and you now install in a temperature of 35 degree, which is a 10-degree increase now. So it means you are automatically reducing the life of that battery by 2. So instead of 4 years, you end up spending 2 years. So after the 2 years, the battery life is gone. Then the customer holds you responsible that you told me that he's going to spend 4 years. So these are things that you need to pay attention to because this system involves money. And like I said, in residential, you might get with some of these things. But for commercial system, or maybe a system where you provide energy as a service or power as a service, which means you are going to be paid as you generate. So if your system is not properly installed or is not installed in a well-ventilated location, it will affect what you're going to generate, and at the same time, it will affect your revenue. Okay, and it will short the life of also the system. So the battery, I think I've mentioned battery. Let me move faster. How many minutes do I still have, please? How many minutes?
5 minutes.
5 minutes. Okay, good. So let me just go straight to protection. We can read about lithium batteries. Okay. Then connection, we have series and parallel connection. And we have series connection, parallel connection, series and parallel connection. Good. This is what we call combiner bus. You can see that cables from your PV array are into the combiner bus. Then you have a surge protector. a DC surge protector on the combiner bus. This is your mounting accessory. Now, this enables you to create air gap between the roof and your PV modules. Now, look at some of the accessory here. Here I have a thin copper and a bare copper. For your solar installation, it's better for you to use a thin copper than to use a bare copper. And the reason is that your installation is outdoor, so the cable is going to be exposed to corrosion also. So the thin copper is better because it can withstand, it has a high tolerance for corrosion. Okay, then this is the DC surge protector, which we're also going to be seeing it in the video that you will come up later. Okay, good. Let me move faster. System protection, in as much as your safety is very important, so also the safety of the components. Okay, so safety of the system. You have to protect your installation against external voltage and also internal voltage surge. And doing that, there is need to install a lightning arrestor for your installation. This is a lightning arrestor, and you know lightning is as a result of build up charges in the cloud. And for the cloud, the charges, we have the negative charges at the lower level, and at the upper level we have the positive charges. While on the ground, under the ground, the negative charges are the lower level and the positive at the upper level. And that's why you see that your lightning arrestor here is connected to the ground, and it serves as a path, creating a shortest path now for the surge current to flow to the ground, because electricity or current will flow through the shortest path to the ground. Okay, so there is need for you to provide a lightning arrestor to protect against external surges. These are typical example or pictures of some of these the lightning arrestor accessory. Okay, then over voltage, there is need for you to install a breaker for your installation. And please pay attention to what we call, there is ICU and the ICS of your breaker. So the ICU is simply the ultimate breaking capacity of your breaker. That is the maximum fault current that your breaker can withstand without being damaged. While the ICS is the service breaking capacity of your breaker, which is the fault current that the breaker can repeatedly interrupt without losing its reliability. So for instance, the load, your current demand is about 10 amp, and you install a 16 amp breaker, which is the ICS now. It means if the current exceeds 16 amp, the breaker is going to trip off. Then you check what actually caused this, rectify it, and when you put on the breaker, it comes on again and current flow. But for the ICU, which is the maximum fault current it can withstand without being damaged, if it is 32 amp and the maximum fault current in your system is 35 amp, it will destroy the breaker. Then talking about breaker, also there is a DC breaker and there is a AC breaker. The AC breaker are for the AC side of your system, while the DC breaker is for the DC side of your system. So please don't use DC breaker for AC breaker. I've seen installer telling you that it doesn't matter, it's going to work. Now, a 5 amp DC current is not the same as 5 amp AC current, because in AC current we factor out what we call the root mean square. So for instance, your 5 amp DC current to the equivalent to AC current is 5 amp divided by the square root of 2, which is 3.5 amp. So your 5 amp AC current is equivalent to DC current is the 5 amp multiplied by the square root of 2. So which is actually about 7 point something amp. So you can see that this is going to affect you in the choice of the breaker. Okay, good. Then also fuse. Make sure you use the right fuse. I've talked about surge protector to the ground. Okay, the non-current carrying conductor is to be what connected to the ground to prevent electric shock, so that when you touch the body of the inverter, or the customer touch the body of the inverter, it will not be electrocuted. So there is need for you to connect to the ground. Yes, just as the safety of you is important, so also the safety of your component. Thank you.
Wow, it's been so amazing. Thank you so much, Engineer Simon, for pouring in the wealth of knowledge, 10 years plus of experience. We would have loved to have more interactions and questions coming on board, but I understand our time has really been fast. Shalom is.
Can you hear me?
Yes.
While the question, everyone is still preparing their question, I would like to show a little video of a demonstration, a typical solar installation demonstration. So bear with us just to see this video, and you can put your questions in the chat box.
Through this solar panel,
Can we hear
we
it?
can charge a battery, and through this battery, how to glow a bulb. I'm going to tell you this whole process. In this process, I will explain you whole connection and which device is used and why it is used. I'm going to explain you everything in detail. This solar panel here, power supply from this solar panel cannot be connected directly with the battery. We can't do this because this solar panel here, through this solar panel, we get DC power supply in output, and voltage of this DC power supply always varies. To charge this battery, if we provide high voltage, then in this condition, our battery may get damaged. To charge this battery in a proper way, we use solar charge controller. To this controller, we can directly provide power supply through solar panel if we want to. But if you want the whole connection in a proper way, then in between you can use a protection device. Like this MCB here, if you connect this MCB, then you will get protection from overload and short circuit. Besides, you must use surge protection device also. Benefit of using this surge protection device is if there is any voltage surge in output power supply. I mean, if suddenly there is increase in voltage, then in this condition, this device will ground the voltage so that all the devices in your home get protected. For now, I am doing connection of these. Friends, in your solar panel, at the back side, you will find two terminals on which you have to connect positive and negative wire. So I connected these wires, and by connecting wires, here I provided input power supply to MCB. Now for connection of this SPD, what you have to do, this negative power supply here, with this supply, loop a wire, and here negative symbol is there. So with this terminal, connect this wire. Take positive power supply and connect with positive terminal. After this, you can see here is earthing terminal. So whatever earthing you have in your home, connect earthing with this terminal in this way. So connection of SPD is completed. Now what we have to do, this MCB here, with output terminal of this MCB, first of all with output terminal, connect one wire, and to this solar charge controller at 1 number terminal, you can see a solar panel symbol is there, this side plus and this side minus symbol is there. So where plus symbol is there, connect this wire with that terminal. Now from second terminal of this MCB, connect one wire, and to this charge controller, provide negative power supply. So we did the connection of solar panel with charge controller. Now if you want that through this solar panel, directly you can glow any bulb, then for this, what you will do is, this charge controller you have, in this you will find DC power supply here. These two terminals are for DC power supply. Among these two, first terminal is for positive power supply So from this point, connect a wire, and to this bulb here, provide positive power supply to this bulb. From second terminal, you will get negative power supply. So take this supply and connect with bulb. If you do the connection in this way, then your bulb will work through power supply from solar panel. I mean, till the time this solar panel is producing power supply, only till this time this lamp you have will glow. The moment at which solar panels stop producing electricity, your lamp will turn off automatically. Now suppose this lamp you have, if you want this lamp to glow even when the solar panel is not producing electricity, then in this condition, you need to use a battery. For connection of this battery, what you will do, here you can see two terminals. Among these two, first terminal is for positive power supply. So from this terminal, connect one wire, and with positive terminal of battery, connect this wire. Now from second terminal, connect a wire, and with negative terminal of battery, connect this wire. So connection of battery is also done. Now through this solar panel, the electricity which is produced, that will be used to charge the battery, and along with this, to glow this lamp, power supply of solar panel will be used. Now suppose this solar panel you have, through this electricity production is stopped. Then in this condition, this lamp you have, this lamp will glow through the power supply of battery. Friends, in this connection, you can see this lamp I used, this lamp will operate on DC power supply. Normally in our home, bulb which we use operates on AC power supply. We don't use DC bulb. If you want to make direct connections, then by using DC bulb, you can do direct connection. But if you want to glow AC lamp, then you have to use inverter. I used a simple inverter here. We also call this inverter as power inverter. At the backside of this inverter, you will find two cables, which is going to be connected with this battery. So what I will do, from here, connect the wires with this. I am showing you from here, but you can do connection from charge controller, or with the terminal of battery you can do the connection. Now in this inverter, you can see a socket is provided. Through this socket, you will get AC power supply. So for connection from here to the bulb, you need to use a plug top. So with this plug top, connect the cable inside which two wires are present. One wire will be used for phase supply and another wire will be used for neutral supply. So I provided phase supply and neutral supply to this bulb. So I connected this bulb with this plug top, and now if I connect this plug top with this inverter and this switch here, if I turn on this switch, then in this condition, this bulb here will start glowing. Friends, this connection I shown here, in this connection, I used only single bulb. If you want, in place of single lamp, you can provide power supply to all the lights in your home. What you have to do simply is take this plug top with this power supply and the MCB of your home, I mean the MCB for lights, connect this with the MCB. Benefit of connecting this wire with MCB is wherever the power supply is going through MCB, in all those places, power is supplied through inverter. Friends, if you want to know how many types of protection devices are used in our home, then click on the right hand side video. Thanks for watching this video.
Okay, go ahead. Go ahead
Okay,
to
good.
take the question.
Can I saw some question here in the chat box.
Yes,
Okay,
yes,
good.
yes.
Okay, good.
Uh,
There is one from Uzochukwu. Uzochukwu is asking if you need to change the capacity of the inverter. No. The data sheet of that inverter that I show you, which is a 15 kVA Vitron, you will see that there is a continuous power output at different temperature level. So there is also, I think, 65 degrees Celsius, the output, continuous output there is 7,000 watts. So in your design, you need to study the data sheet to know the maximum temperature that the inverter can withstand and what is the output of that of the inverter at that temperature. So you need to size your inverter, you need to size the system to be able to handle that peak, because during your site analysis, you already know, okay, the temperature of that site, okay? And during installation, that's why you need to install your system in a well-ventilated location. In fact, that, like for banks now, you see in banks, they have an air condition, even installed where they have the battery and their inverter. So you don't need to change the capacity of your inverter as the temperature increase. No, you need to play at the maximum. Like for instance, now, if my continuous load is 10,000, for instance, now is 10,000, and I know that this site location, the temperature might likely hit up to 65 degrees Celsius. Then in such installation, I will not deploy a system that would not be able to handle that capacity. So you don't need to change the inverter capacity. You need to study all this before you even deploy, and make sure that at no point will the load increase, okay, beyond what the inverter can handle at different temperature level. Okay, I see another question asking about okay, about the life of the battery. Yes, increase in temperature affects the life of the battery. And I say this is pure chemistry. The rate of chemical reaction increase as the temperature increases. And from research, for every 10-degree increase, the rate of chemical reaction is like almost ×2. Okay, so which means if your battery is expected to spend 4 years, because another thing is that the issue we have with installer is that they don't study the data sheet, or some of them don't even know how to read this data sheet. Because some of the complaints that I hear from people, by the time I study the system, those batteries are actually doing what they are designed to do. Okay, there is what we call the C rating of batteries. Okay, the C10, the C20, up to the C100. So this battery, they have specification and application. So you cannot be using C20 for a C10 application. It's going to affect the life of that battery. Okay, so your battery need to be installed in a well-ventilated. When you study the data sheet, you will discover that this component, they are actually designed and tested at room temperature, at a temperature of 25 degrees Celsius. And they will also tell you when you go beyond this, this is what you're going to get. Okay, so it is very important to study it so that to know if your battery is going to be will be discharging at a temperature that is higher than what is specified for a particular number of years. Okay, then the depth of discharge also play a role. Okay, the depth of how deep you discharge your battery also affects the life of these batteries. Let me see if there's any other question for me. I think that those are the 2 questions for me.
Well, yeah, wonderful. Thank you so much, Engineer Simon, for responding to those questions. I'm sure those are very wonderful answers. We have just about 1 or 2 questions which Engineer Bello will respond to. Enoch was asking which open source softwares should he learn to up his solar designing skills? And maybe just to be a little bit futuristic, I know you're a mechanical engineer and most of the things you maybe want are mechanical. But what is the future of AI and automation of this solar design installation? And yeah, we just want that engagement perhaps get to the end of this. Thank you.
Okay, Shadrach.
I can't get you. Hello. Still can't get you.
Mr. Bello.
Hello, can you hear me?
Yes.
Yeah, I said, do you want me to answer both questions?
Yes, the question Enoch was asking, which open source software could he learn to
Okay.
upskill his
So
knowledge on design, solar design? But then I was asking for an engagement from you on the future of AI in automating the whole designing and solar installation. And yes,
okay,
that's the
okay.
conversation we want to see coming from the end of this.
Thank you for those. Okay, so on the open source software, has a web version that's open source, I think to a limit, but I've never used it.
Yes.
Get the name.
I've also heard that there's Helioscope, right? But I've not used open source software before, right? Most of the time I had to use software, and they have been fully licensed institutional
Okay,
software.
it seems it's
But
having network issue there. Can I just answer that?
Yeah, fine.
Okay, PVCs also. PVCs, there is PVCs and there is also OMA software. I think it's already in the chat box. Yes. Helioscope is also one of the software that you can learn. And I think for the structural design, you can also do a SketchUp. These software are available for you to, in fact, as you go into a bigger system, you will need this software to for your design. Then another thing is that the manual design is also very important. You need to understand the manual design, the manual calculation, because if you don't understand it, it might be difficult for you. In fact, it's going to be difficult for you to be able to lay your hands on this software. So you need to understand the manual, then you can benchmark it with what the software is going to give you. And for the AI, I think the AI has come and is going to really be a game changer. Like for the issue of temperature now, with the introduction of AI, you can be in Nigeria and be able to extract or extrapolate and get analysis of data of a particular site, even in Canada, in Europe, in whatever location. Okay, so AI we can assist for you to be able to see maybe for a period of 20 to 25 years or 30 years, what has actually been the maximum temperature of that particular location. Because also your PV module, as not only the inverter, your PV module, your solar panel, as the temperature increase, the output also drop. Okay, then even voltage, as the temperature increase, the voltage also drop. And some of these inverter, there is a minimum and a maximum that the voltage has to be for it to work effectively. If you operate at the minimum, the worst that will happen is that the inverter will not work. But if you play at the maximum, you might damage some of the components. So with the introduction of AI is going to really change a lot of things, and is going to make some of this data analysis, data collection very easy for a designer. Yeah.
Wow, thank you so much.
hello, Shadrach, can you hear me now?
Oh, yes, we can hear you.
Okay, sorry, I think it was my network the other time. But just in addition to, I think Shalom has mentioned the softwares already, but just in addition to the AI conversation, it's just like Engineer Lowo did mention, nobody can really predict what AI is going to become, right? But I think one key area in which AI is going to change things really is going to be in terms of predictive modeling and maintenance, right? So in cases, especially in very hot regions where these temperature issues are going to be a problem, one of the things that is going to be is going to be forefront of research now is how to incorporate AI automation to see how you can manage some model situations, especially in places where you have no choice but to use those systems in those kinds of places. You want to see how you can make a system where you can manage those kinds of situations, whether for disconnection, predictive maintenance, as the case may be. That's going to be another big frontiers. And it's already taking center stage in other industrial space. I know it's just a matter of time before it takes a center stage for PVC. I just thought to also add that. Thank you.
Let's take a good picture. Go ahead. Okay. Can we turn on our cameras? Thank you so much, Engineer Simon and Engineer Bello. Can we turn on our cameras for a group picture? Yeah, if you are in a comfortable place, please would like to get a picture with you. And in the chat box, I think Enoch will be sharing the call for energy educators. So Renewables Technologies said, like Shadrach is one of our energy educators here at Renewables Technologies, and there is an open call. So the link will be shared in the chat box while we are all turning on our cameras. Lovely to see you out live. Are we getting more cameras turned on? Hi, Izube. Hi, Enoch. Great to see you. Hi, Kenneth. I know that most of the names are familiar based on LinkedIn, and it's so great to see everyone. Thank you so much for joining. Thank you. Hi. Hi, Mark. Oh, it's fine. It's okay if you can't turn on your camera. So I'm going to be taking the pictures now on the count of 3. Or should we? So at the count of 3, we all shout solar. Then I'll take the picture. So 1, 2, 3, solar. All right. Thank you so much. Thank you so much. Engineer Simon has shared his LinkedIn connection link in the chat box. We also have the call for energy educators in the chat box. Please connect with Engineer Simon. Also, you can check out Engineer Elesami Bello on LinkedIn as well. And we look forward to more conversations like this. Remember to look out for our February edition of Renew Education. It will still be coming up on our LinkedIn page. Thank you, everybody. Thank you so much, Shadrach, for the great moderation today. Thank you so much. And this is the end of the section. Thank you so much, Mr. Simon. Thank you so much. And thank you so much, everybody, for joining.